All right, good afternoon, everyone. Today I will talk about testing of companion apps and specifically apps that connect to physical hardware over Bluetooth. And I will show you how we managed to improve test coverage and shorten release cycles by utilizing hardware simulation and AI-generated tests. I will present together with Oskar, who will take over the second part and talk about the role of Petrol and our AI-assisted test generation workflow. First, a few words about myself. I'm Eduard Siewert. I work as a software architect at Sennheiser since 2017. I've been working with Flutter since 2020. And in 2022, the Sennheiser consumer division got acquired by Sonova, so that's why you might hear both names throughout the presentation today. So first, a bit of context. This is the Smart Control Plus app. It's a Flutter app available for iOS and Android, and it's the main companion app for the Sennheiser headphones, earbuds, soundbars. And most of the features control an actual feature of the headphone that is connected via Bluetooth. Currently, we support around 20 different products, different communication protocols, different connection interfaces like Wi-Fi and Bluetooth. And on top of that, each of the products has different firmware versions with slightly different capabilities. So this creates a pretty large configuration space. And as you can imagine, this makes testing uniquely difficult. And so relying on manual testing only is not an option here. So the question is, how do we test this reliably and at scale? So the traditional model that we see here is a testing pyramid, where we sort the different testing strategies according to their costs. And on the very top, we have manual testing, which usually includes end-to-end testing with the real hardware. And this focuses on all the scenarios that are very hard to automate reliably. And because these tests are expensive to run, they are usually concentrated just before releases. On the contrary, at the bottom, we have a large base of unit tests. These are headless and therefore very cheap to run. So usually we run them on every pull request. And unit tests are the fastest signal that we have for regression of isolated single components. They work great as a feedback loop for AI coding agents, but they can also create noise if they test implementation details rather than behavior. But the real problem here is the test coverage. So especially in a companion app, you have a lot of scenarios that you can only reliably test with integration tests. So you have a multi-step device interactions, upgrade flows, connect and reconnect scenarios, events that are sent from the headphone towards the app. All of these cannot really be covered with unit tests. And our goal would be therefore to increase the number of integration tests and therefore increase our test coverage. So eventually we would like to move from a testing pyramid to a testing diamond. In a testing diamond, the integration tests are the focus of our testing. But to make this practical, we need to solve two issues. First, it's the issue or the cost of running integration tests, and then also the cost of writing integration tests. So how do we make integration tests cheaper to run? The natural answer is device farms. So you have actual phones in the cloud running tests in parallel. And for most of the IOs of the app, this works pretty well. So we have some cloud endpoints that you can hit, so HTTP requests that you can that can hit the staging environment, or we can mock the endpoints. We have hardware capabilities of the phone, like the memory or location, which we can also use in the cloud, or we can also mock them. We have the touch interface, where we have tools like Petrol that are specifically built to simulate these inputs. But one important I/O is missing in the cloud, and that's the actual headphone. You cannot connect a headphone in a device farm. So you have to find a different solution. And you might say, okay, then we just mock this headphone. But a mock is not enough. A mock doesn't have a state. What we need here is a real simulation of the hardware. So that's what we call a fake. A fake has real logic. It has a state. It reacts to requests from the app, just as a normal headphone would do. So when the app, for example, sends a command to turn off the noise cancellation, the fake parses the request, updates its state, and responds back to the app. So that's the key distinction here. A mock is a scripted expectation, while a fake is a stateful simulation of the headphone. So here, just a small overview of the different layers of the fakes and the app. So on the fake side, you can see we have the so-called device fakes that simulate the transport layer behavior, like Bluetooth advertisements, pairing, connection handling. Above that, we have a protocol layer that parses the incoming bytes and forwards the data to the according features. We have the feature fakes that can be anything from noise cancellation, firmware update, equalizer. They receive the data, update the state, and send the according response back to the app. And in order to make, or in order to allow the app to talk to the fake, what we do is replace the transport layer in the app during tests. So instead of using the real Bluetooth plugin, for example, we replace it with a test implementation that forwards the byte stream to the fake instead of sending it out via Bluetooth. So from the app's perspective, everything stays the same, just the transport layer is swapped. And for test authors, the fakes expose a fluent test API, and they mirror real-world device interactions. So you have methods like fake turn on. It simulates that the headphone powers on and appears in the BLE scan results. You can change the physical state of the headphone, so you can simulate that you put it on the head, take it off, and it sends the according events to the app. You can change the battery level to simulate a draining battery. So all of this allows it for the test authors to focus or think in terms of device behavior rather than protocol internals. They don't need to know anything about the implementation details. And it also makes the test intent easy to understand for code reviewers, so that also helps the quality and the team velocity. So yeah, this was the first part about product fakes and how they allow us to reduce the cost of running integration tests. And now Oskar will take over in the second part and explain us how we manage to reduce the cost of writing integration tests by utilizing petrol and AI agents. Thank you.
Okay, thanks, Eduard. So, yeah, first of all, my name is Oskar, and I am QA automation engineer at LeanCode, part of Patrol team, and also lately author of Patrol MCP server. Let me take a look what happened. Okay, great. And let's start with some short Patrol introduction for those who don't know. So Patrol is end-to-end testing framework written specifically for Flutter. It allows you to write tests for all of the mobile platforms for Android and iOS. You can write tests for Flutter for web and also macOS. And later you can run those tests on all of the major device farms. Besides that, you write test code in Dart. The Patrol allows you to do some direct upstate interaction, and also Patrol has some AI tooling included. But I want to think of Patrol as an enabler. So in case of Sennheiser, the patrol allowed them to use the fakes the way they do, so they could automate those tests without some very complex simulators that wouldn't be very reliable, and they could use fakes. The other thing that patrol allows you to do is better test coverage, because of those direct upstate interaction, you can automate scenarios that would not be possible otherwise. Now let's talk a bit about AI in testing. So testing nowadays is even more important because we have a lot of AI writing new features, AI helping you ship everything faster. So the new question rises, is it okay to use AI to write tests which will be testing features written by AI? My personal answer is yes, but only if you pay a lot of attention to the quality of your code. And the next question then rises, how can you do that? So first of all, mobile developers get a lot of cool tools which were mentioned today. So they get Figma MCP, they get Marionette. And what about end-to-end testing? Well, for that, we have Patrol. So first of all, Patrol comes with some AI rules or cloud skills for writing Patrol tests, which are already in Patrol repository. So that's how you can improve the quality of the code written by your AI agent. Also, we have included in those rules test architecture, which you can use or you can decide to not to use it if you do not agree with it, but this is something that you can do to further improve the AI agent code. And last but not least, we have an MCP server. So what's the point of this MCP server? The main goal of it is to allow AI agent to do the same things that QA manually writing patrol code would have. So the first thing that we allow with this MCP AI to do is to take device screenshots. We can take a look how that looks. And because of those screenshots, we gain two things. First of all, AI from now on has eyes when writing patrol tests. So in case something fails, the test fails, the AI can take a look at the screen and see what happened, because logs sometimes might not be enough to determine what was the problem. Especially if something in backend is wrong, we will get some generic response, but then the error would be visible in the emulator. Another case is that if we are writing new tests, the screenshot might help AI determine what was the last state of the app at the end of the test. So later it can incrementally add new test steps at the end and continue writing more and more complex test scenario. The other thing that MCP enables your AI agent to do is to build the app once and then rerun it with changed test code instantly, which makes a pretty decent development loop. And yeah, let's take a look at that. So on the right-hand side, you can see a very simple prompt, which just tells AI to automate some 1, 2, 3, 4 test case from Azure. And later, we are just saying that we want to use fakes and patrol rules. So AA starts by just reading the context, pulling everything from Azure. It tries to write the test blindly, so it starts by writing the code. Later, we can see the initial build. So the test is built. It was not completed. We have second attempt. Again, something went wrong. And the third attempt, the test has passed. So we have, with a single prompt, and the whole pipeline took about 10 minutes. We have a automated test scenario which was pulled from our Azure. So this is an actual test case that we have in our pipelines, which is very cool in my opinion. But yeah, the gain that we get from this patrol MCP server is that the AI agent can reliably use patrol. It can get all the context that AI would have. Okay, but let's assume we've used patrol MCP with lots of success. We have a very big test suite. And later, we come to work the next day as QA, and we see some failed runs. This is basically bread and butter for QAs, unfortunately. But yeah, whenever we can see some failed tests, most of the time there are three possible results. First of all, the app that we are testing has changed because there was some change request, user story, and the flow for existing tests changed, which was expected. In this case, we need to confirm that manually as QAs, which takes time, and update our tests, and then we are fine. The other case is when we have an actual bug. Then basically the same flow. We need to report the bug before we need to investigate what went wrong. So the bug report isn't very vague. We can confirm it as QA what was the root cause and report it well. And the worst case, at least from QA perspective, is a flaky test, which basically means that our test fails every 10th time. We have absolutely no idea what happens. Maybe the backend response is not always the same. Maybe we have some race condition. The investigation for those is the worst thing that you can do as QA because it's never easy. And because we have Patrol, which lives in the same repository as our app code, then when we are using AA agent, we have test code, we have app code, we have all the typical tools, so we have access to Git, we can have Jira connectors for some additional context, and if we, of course, patrol MCP to run the test which failed on CI locally to confirm, for example, that it's not flakiness. And if we put all of that together, we can run AI, which will do all of this investigation. And it's much, much more easy to, for me, for example, to start my day running such AI and then seeing the output after a couple of minutes with very likely root cause for this failed test than to do the whole investigation myself. So this is a very simple use case for AI, but it basically removes one of the biggest pain points for QAs, which takes a lot of time and it takes a lot of energy out of you to run and try to blindly find the root cause for flaky tests. Okay, so let's summarize everything. So first of all, those fakes that Eduard mentioned can enable you to test the applications that otherwise would have to be tested manually or maybe mocked, which would not be as good as those fakes with the approach that was shown. And because we can combine that with device farms, this significantly reduces the costs of your end-to-end tests. And because you are able to write more automated tests, then your test coverage improves a lot. And from the AA perspective, since we are shipping everything faster, then tests are even more important today than they were ever. And also, AI can be used for writing tests, but then you need to start paying more and more attention to the quality of your test code. So yeah, proceed with caution and try to keep your test as good as you can. And that's all from my side.